Have you ever stopped to consider where the power that charges your phone or lights up your house comes from? This question may seem trivial, but the answer holds the key to understanding one of the most pressing issues of our time: the energy conundrum. Every time we flip a switch, power up a device, or take a drive, we're tapping into energy resources. But here's the catch. A significant portion of this energy comes from non-renewable resources like oil, coal, and natural gas. These resources have powered much of our civilization's progress, but their use comes with a hefty price tag. They are finite, and their extraction and use contribute to environmental degradation and climate change. Now imagine a world where we could generate power without harming our planet. A world where energy comes from clean, renewable sources. This is not a distant utopia, but a reality we can create with today's technology. The shift towards clean energy is not just about preserving the environment. It's about securing a sustainable future for generations to come. Among these cleaner energy alternatives, solar energy shines brightly. It's not just because the sun is an abundant and consistent energy source. Solar energy, unlike fossil fuels, does not produce harmful emissions or contribute to climate change. Moreover, it's a resource that's accessible to almost everyone, everywhere. But the switch to solar energy is not as simple as it sounds. It involves a complex interplay of technological, economic, and political factors. For instance, while the cost of solar panels has decreased over the years, the initial investment can still be substantial. And while many countries are investing in solar power, others continue to rely heavily on fossil fuels. So, what can we do about it? How can we make solar energy not just an alternative, but the primary source of power? These are the questions we need to explore and answer. There's an urgent need to switch to cleaner energy sources, and one of the most promising options is solar energy. Let's delve deeper into this fascinating world of harnessing the sun's power and see how it could light up our future. What if we told you that every day an untapped reservoir of power lights up the sky? That's right, we're talking about the sun. The sun is a powerful source of energy, and it's this energy that we refer to as solar energy. Solar energy, in its simplest form, is energy from the sun. It's a type of renewable energy that's abundant and freely available. The sun's rays that reach the earth in just 1 hour could meet the world's energy needs for a whole year. That's a lot of power waiting to be harnessed. But how do we harness this power? Well, it's all thanks to a process called the photovoltaic effect. This is a physical and chemical phenomenon where certain materials can convert light into electricity. This is the principle behind the operation of solar cells, which are the building blocks of solar panels. Solar panels are made of many smaller units called solar cells. Each of these cells is made from a material that can absorb sunlight. When sunlight strikes the cells, it excites the electrons in them, creating an electric current. This is known as the photovoltaic effect. But it's important to note that not all sunlight can be converted into usable energy. Only certain wavelengths of light are effective in generating electricity. This is why solar panels are designed to absorb as much of this effective light as possible. Moreover, the efficiency of solar panels also depends on the intensity of sunlight, which can vary depending on the time of day, the season, and the location. This is why solar panels are often installed in places with high sun exposure and are tilted at an angle to capture as much sunlight as possible. So, solar energy is not just about soaking up the sun. It's a sophisticated process that involves the conversion of sunlight into electricity using the principles of physics and chemistry. It's a promising solution to our energy needs, offering a renewable and clean source of power. So, solar energy is essentially harnessing the power of sunlight. But how exactly does this process work? Well, that's a question for the next scene. Stay tuned. Believe it or not, the process of converting sunlight into electricity isn't as complicated as you might think. It's a fascinating journey of photons, solar panels, and photovoltaic cells. So let's dive in. The adventure begins with the sun, our very own star. Every second, the sun sends out an unimaginable number of photons, tiny packets of energy racing towards Earth. Some of these photons, after an 8-minute journey, reach our planet and become the key players in the process of solar energy generation. Enter the solar panel, the superhero of our story. The solar panel, typically installed on rooftops or in open fields, is like a photon catcher. It's made up of several smaller units called photovoltaic cells. But what's so special about these photovoltaic cells? Well, They're made of two layers of a semiconductive material, usually silicon, that's been doped with certain elements. This doping creates an environment where the top layer is positively charged and the bottom layer is negatively charged. This difference in charge is critical, as it creates what we call an electric field. When a photon from the sun hits a photovoltaic cell, it can provide enough energy to knock an electron loose from its atom. If this happens within the electric field, voila! The field will send that electron scurrying along in a directed path, creating a flow of electricity. And there you have it. That's the basic principle of how solar panels work. They take the energy from the sun's photons, use it to knock electrons loose, and then harness the resulting electric current. And just like that, the sun's rays are transformed into usable electricity. But what does it take to set up a solar power system? While the sun's energy is free, harnessing it does come with a price tag. To transform the abundant solar energy into usable electricity, we need solar panels, and manufacturing these panels involves certain costs. One of the main components of solar panels is silicon, which needs to be mined and then processed into a very pure form. This process involves a substantial amount of energy, hence the cost. Besides silicon, there are other materials like silver and aluminum used in the construction of solar panels, adding to the overall cost. Then there's the cost of the inverter, a crucial piece of equipment that converts the direct current produced by the solar panels into alternating current that our homes and businesses can use. Add to that the cost of mounts to hold your panels in place, wiring to connect everything together, and batteries if you want to store energy for use when the sun isn't shining. After the hardware costs, the next big expense is installation. Installing solar panels is not a DIY task. It requires a professional who can safely mount the panels on your roof or another suitable location, connect the system to your power supply, and ensure everything is working correctly. But once the initial investment is made, the running costs are minimal. Solar panels require little maintenance and can last 25 to 30 years or more. Plus, the electricity they generate is free. This means over time, the cost of solar power often ends up being less than what you would pay for electricity from the grid. In many areas, you can even sell excess power back to the grid, earning you money or credits on your electricity bill. There are also various incentives like tax credits and grants available in many places to help offset the upfront costs. So, solar power can be a significant investment upfront, but the potential savings and benefits over time may well make it worthwhile. With the added benefits of reducing our reliance on fossil fuels and contributing to a cleaner, greener planet, it's an investment that can pay off in more ways than one. How does solar power stack up against traditional energy sources like coal and natural gas? Well, let's start with the environmental impact. Solar energy is a renewable source, meaning it's continuously replenished by nature. We can harness the sun's energy every day for as long as the sun keeps shining. On the flip side, conventional fuels such as coal, oil, and natural gas are non-renewable. They take millions of years to form, and once consumed, they're gone for good. When we burn these fuels for energy, they release harmful pollutants into the atmosphere, contributing to climate change. Carbon dioxide, methane, and other greenhouse gases trap heat from the sun, causing the Earth's temperature to rise. This phenomenon, known as global warming, is leading to an array of environmental problems, including extreme weather events, sea level rise, and loss of biodiversity. Solar power, however, is a much cleaner option. The process of converting sunlight into electricity doesn't emit greenhouse gases or other pollutants. It's a silent process that doesn't contribute to noise pollution either. Now let's talk about the concept of renewable versus non-renewable resources. As mentioned earlier, solar energy is renewable. It's a virtually inexhaustible source of power that's available to us every day. Conventional fuels, being non-renewable, are finite. Are we on the brink of a solar-powered future? This is a question that has intrigued scientists, environmentalists, and policymakers alike. As we grapple with the mounting challenges of climate change and energy security, it's time to delve into the potential of solar energy as a key player in our future energy solutions. The potential for solar energy is astronomical. After all, the sun is the most abundant source of power on our planet. Every hour, the sun beams down more energy than the world uses in an entire year. Imagine harnessing even a fraction of that energy. In recent years, we've seen an impressive surge in solar power usage. Thanks to technological advancements and economies of scale, solar power has become increasingly accessible and affordable. The cost of solar panels has plummeted by more than 70% in the last decade, making solar energy a viable option for many households and businesses. Moreover, recent advancements in solar technology are pushing the boundaries of what's possible. For instance, perovskite solar cells, which are cheaper and more efficient than conventional silicon-based cells, are showing great promise. And then there's the emerging field of solar fuels, which aims to convert sunlight directly into liquid fuels. Looking ahead, the future of solar energy seems incredibly bright. Global solar power capacity is projected to triple by the end of the decade, and solar could become the world's largest source of electricity by mid-century. This growth will be driven not only by the falling costs of solar technology, but also by the increasing urgency to transition to clean, renewable sources of energy. However, realizing this solar-powered future won't happen overnight. It will require concerted efforts from governments, businesses, and individuals alike. We will need to invest in research and development, build the necessary infrastructure, and create supportive policies and regulations. The sun offers an abundant, clean, and increasingly cost-effective source of power. The future of solar energy looks bright indeed. So let's not shy away from the challenges ahead. Instead, let's embrace the opportunities that solar energy presents. After all, the future is ours to shape. So, let's recap what we've learned about solar energy. We've unraveled the energy conundrum and delved into the fascinating world of solar power. It's clear that the sun, our very own star, is a boundless source of energy. We've dissected the science behind it, understanding how photons become electricity. We've also looked into the costs involved. And while the upfront investment might seem steep, the long-term benefits outweigh the initial costs. We've compared solar energy to conventional fuels, and the verdict is clear. Solar is a cleaner, more sustainable option. We've peered into the future, and it's bright with the promise of solar energy. The transition to solar isn't just an environmental need, it's an economic opportunity, a chance to build a sustainable future. As we look towards a sustainable future, it's clear that solar energy will play a pivotal role. The power to make a difference is, quite literally, in our hands.